Hello students, welcome back to Effortless Chemistry. Already we have started group 15 of the P block elements, and in the last session we have covered up to the preparation and properties of nitric acid. Now we will discuss the oxidizing property of nitric acid. That is very important question will come from this concept. So oxidizing property of HNO3. Oxidizing property of HNO3. Okay, so already we know that what is oxidizing agent. A species which gives a nascent oxygen is called as oxidizing agent, or a species which undergo reduction, that is what called as oxidizing agent. So first I'll write what is oxidizing agent, OA. I'll write oxidizing agent is what, which gives nascent oxygen. Here the nascent oxygen is nothing but it is a highly reactive elemental oxygen, that is called as what, elemental oxygen. This is so reactive that anything that comes in contact with this one, this oxygen will readily combine with that species. So this is called as what, nascent oxygen, which is highly reactive in nature. So the addition of oxygen is nothing but what, oxidation. So the species which are giving nascent oxygen, they are called as oxidizing agent. So here oxidizing agent which gives a nascent oxygen, and this oxygen is added to the other species, and that species get oxidized here. And this oxidizing agent, this is the first point of oxidizing agent. Second one is the species which undergo reduction is what, oxidizing agent, which undergo reduction, is called as what, oxidizing agent. Which undergo reduction means its oxidation state will decrease here. Now we will see the oxidizing property of HNO3. This HNO3 is also a very good oxidizing agent because on heating it decomposes to give the nascent oxygen. We will see that HNO3 is a very good oxidizing agent because on heating it decomposes to give nascent oxygen. One thing you keep in mind, nascent oxygen is what, always it is highly reactive oxygen. Okay, now we will see the decomposition reaction of this HNO3. There are two decomposition reactions are there based on the concentration of the HNO3. If we take concentrated HNO3 or if you take a dilute HNO3, you will get different number of that nascent oxygens here. First one, if I take 2 moles of HNO3, I will take, this is a concentrated HNO3, this on heating it decomposes to give, see here 2 hydrogens are there, you take 1 oxygen to form water molecule, 1 water molecule, plus it gives 2 times of NO2, 2 nitrogens are there, you utilize 4 oxygen to write 2 times of NO2, plus see here total 6 oxygens are there, already we have utilized 5 oxygen, only 1 oxygen is remaining, that oxygen is coming out as what, that is nothing but nascent oxygen. So because of this this HNO3 acts as what, oxidizing agent here. If you take a dilute HNO3, I will take 2 times of that is the dilute HNO3. Okay, this upon heating it gives what here, again it gives a 1 water molecule, plus see here if you take concentrated HNO3 on heating it decomposes to give NO2. If it is a dilute one, it decomposes to give NO. So 2 times of NO it will give, 2 times of NO. So totally how many oxygens we have utilized here, 1 and 2, 3 oxygens are there. Okay, remaining 3 oxygens are coming out as what, nascent oxygen. So dilute HNO3 gives what, 3 nascent oxygen. If you take concentrated one, it gives what? Only one nascent oxygen. This is what decomposition reaction of the HNO3. These two reactions are very, very important. You have to keep in mind, because with the help of these basic reaction only we are going to write the oxidizing property of HNO3. Now we will see here. Now this HNO3 oxidizes both metals and non-metals. The products of oxidation depends on concentration of HNO3. So this HNO3, it oxidizes metal as well as non-metals, but the products of oxidation, that depends on what? Concentration of the HNO3, whether you have taken very dilute HNO3 or it is a very concentrated HNO3 or simply dilute HNO3. So based on the concentration of the HNO3, you will get different products of the oxidation. So whenever the metals and non-metals are treated with HNO3. Okay, first we will go for oxidation of the metals. First one I will write oxidation of metals. First I will give the simple basic idea about the oxidation of the metals. Already we know that this HNO3 is what? Oxidizing agent, which gives a nascent oxygen. Then this nascent oxygen reacts with what? Metal combines with this nascent oxygen to form what? Metal oxide. So these metal oxides are what? Already they are basic in nature. Metal oxides, these are being basic in nature. Again they will react with what? Acid here. So they will react with 2 times of HNO3 plus metal oxide. So ultimately what you will get here, in each oxidation product you will get what? Metal nitrate. This metal combines with nitrate, you will get metal nitrate plus 2 hydrogen, 1 oxygen, you will get what? 1 water molecule. This is what the basic idea about the oxidation of the metals by concentrated HNO3. We will see the oxidation of copper here. The first one I will write the reaction of HNO3 with the copper metal. Copper is oxidized to copper nitrate here. First reaction we will write. First one, reaction of HNO3 with copper. There are 2 cases are there. One, you have to take concentrated HNO3 with the copper. Another thing is you take dilute HNO3 with the copper. In both the cases you will get different products, as we have seen the different decomposition of the concentrated HNO3 and dilute HNO3. First one we will take concentrated HNO3 reacts with copper here. Now I will take the decomposition reaction of concentrated HNO3. This is your concentrated HNO3. This on heating gives what here? This is a water molecule plus 2 times of NO2 plus 1 nascent oxygen. So this nascent oxygen given by the HNO3, that will react with copper. This copper will react with the nascent oxygen that is obtained by the HNO3 to form what here? Copper oxide. Okay, this copper oxide being basic in nature, again it will react with what? HNO3 acid. So 2 times of HNO3 reacts with copper oxide. So what happens here? Again you will get copper nitrate and 2 hydrogen, 1 oxygen, you form 1 water molecule. This you will get it as copper nitrate plus water molecule. Now I will write the balanced equation. So this copper oxide, these two get cancelled, nascent oxygen get cancelled. Now you can write copper Cu plus total how many times here? HNO3, 4 times of HNO3, this is concentrated, you write. Then after the aroma you write these things. So totally what you will get? Main product is copper nitrate, CuNO3 twice, plus 2 moles of water plus 2 moles of NO2. So in the NCERT, in the NCERT they have given directly this reaction. Okay, this is the basic thing behind this reaction. So 1 mole of copper reacts with 4 moles of concentrated HNO3 to give the copper nitrate, 2 times of H2O and 2 times of NO2. They may ask one more question, which gas is liberated when copper reacts with concentrated HNO3? NO2 is liberated. In the same way, copper reacts with dilute HNO3 also. This is the reaction given in the NCERT, and this is the basic behind that one. Okay, actual oxidizing property of HNO3. Now I will write the reaction of HNO3, that is dilute HNO3 with the copper. Suppose if I take dilute HNO3, this is the decomposition of dilute HNO3. So this one heating gives what here? H2O plus 2 times of NO plus 3 nascent oxygen. Now I will write again this copper reacts with what? This nascent oxygen to form copper oxide. But here 3 nascent oxygens are there, here only 1 oxygen is utilized. In order to balance these two, this is multiplied with 3 here. So that here also you will get 3 nascent oxygen, 3 nascent oxygen, you can cancel easily. Then this is being basic in nature, again it reacts with what? Acid. This is 2 moles of HNO3 plus you write what? Copper oxide. So again the same product you write here, copper nitrate plus water molecule. This is CuNO3 copper nitrate plus what happens here? 2 hydrogen, 1 oxygen. You can write 1 water molecule. Again, in order to balance these two, 3 times of copper oxide is there, here only 1 time. So this also multiplied with 3 here. Okay. So very simple reaction is there. Now you see here 3 nascent oxygen get cancels, 3 times of copper oxide, these two get cancels here. Rest everything you can write by multiplying the corresponding numbers here. Now you write 3 times of copper reacts with 2 HNO3 and here is what? 6 HNO3, 3 2s are 6 it is. So 8 times of HNO3. Here compulsory you have to mention it is dilute. In case of concentrated it was 4 moles of HNO3, in case of dilute it is 8 moles of HNO3. Then you are getting what? 3 moles of copper nitrate, 3 moles of copper nitrate plus 3 water molecule plus 1, 4 water molecule plus this is what? 2 times of NO. So with the dilute HNO3, copper upon oxidation gives what? NO gas. With the concentrated HNO3, copper upon oxidation it gives what? NO2 gas. This is what? The oxidation of copper metal with the HNO3. These two are the reaction. In the NCERT again they are given this final reaction. Okay, this one they have given directly. If you want to buy it, you can remember this one, or else you can go through the concept. Okay, now the reaction of HNO3 with the zinc. Second one, this is also metal. Reaction of HNO3 with zinc. Before starting this reaction, just I will give one hint. You always keep in mind this zinc with dilute HNO3 and concentrated HNO3. With the concentrated HNO3 it gives NO2 gas. Always you keep in mind, with concentrated HNO3 it gives NO2 gas. With dilute HNO3 it gives N2O gas. Okay, this one you keep in mind first. So first I will write the reaction of concentrated HNO3 with the zinc here. Zinc directly reacts with concentrated HNO3 here. In case of this one, zinc directly reacts with concentrated HNO3. See here, directly I have taken zinc reacts with HNO3 because zinc can easily replace this hydrogen, because zinc being more electropositive than hydrogen. Okay, so this zinc easily replaces hydrogen from the nitric acid. So directly there is a formation of what? Zinc nitrate. Zinc nitrate plus these two hydrogens are obtained as nascent hydrogens here. 2 nascent hydrogens are obtained. These nascent hydrogen, before escaping, they will reduce the HNO3. So again they will react with 2 times of HNO3. Just we are writing the reaction of zinc with what? Concentrated HNO3 here. So they will reduce what? these nascent hydrogens, they will reduce this HNO3. See here, already I have told you, zinc with concentrated HNO3, it gives what? NO2. So 2 times of nitrogen are there, you remove 2 times of NO2 first. You have to remove what? 2 times of NO2. If 2 times of NO2 is removed, what is remaining here? Yes, 2 oxygen is remaining and 2 hydrogen is remaining. Okay, so you take 2 hydrogen here, total 4 hydrogen, 2 oxygen. You can write what? 2 times of H2O. Very simple. See here, from here you have to remove NO2 gas. Since 2 nitrogens are there, you are removing 2 times of NO2. After removing 2 times of NO2, you are left with 2 oxygen and 2 hydrogen. So with the remaining oxygen and hydrogen, we have to form the water molecule. So to form the 2 oxygens are there means remaining is 2 oxygen, means we have to form 2 water molecules. To form 2 water molecules, already 2 hydrogen is there, remaining 2 is required. I have taken these 2 hydrogen from here. So that 4 hydrogen combined with 2 oxygen to form 2 moles of water molecule here. Okay, this is how you have to write the reaction of zinc with the HNO3. See here, again 2 nascent hydrogen cancels. Just this zinc reacts with how many moles of HNO3 here? 4 moles of concentrated HNO3, giving zinc nitrate plus 2 moles of NO2 plus 2 moles of water. This is what the reaction of zinc with the concentrated HNO3. Zinc metal is oxidized to zinc nitrate here. Okay. Next one we will write the reaction of zinc with the dilute HNO3. With dilute HNO3 it gives what? N2O gas. Now see here, simple logic I will give you for that one. Now the reaction of zinc with dilute HNO3, zinc reacts with 2 moles of HNO3 which is dilute. Okay, always you keep in mind, whenever zinc reacts with HNO3, you have to write directly zinc nitrate, because this zinc easily liberates the hydrogen from the HNO3. One thing you keep in mind, it will come in the electrochemical series. For the metals which are before hydrogen, they can easily liberate the hydrogen. But in case of copper, what happens? Copper is present after the hydrogen in the electrochemical series. This copper cannot liberate the hydrogen. So this will come in the electrochemical series. Again, that is in the electrochemistry, you will come to know that one. For time being, you remember that zinc is present before the hydrogen in the electrochemical series, so that it liberates hydrogen easily. But in case of copper, that is not possible. That's why there we have given nascent oxygen, and here we have taken what? Nascent hydrogen here. So here what happens? Again, you form zinc nitrate plus 2 nascent hydrogens are obtained here. These nascent hydrogens, they will reduce nitric acid, okay, to the different nitrogen oxides here. Then already we know that this zinc on treating with dilute HNO3, it gives what? N2O gas. So first we will write 2 times of HNO3. From this one, what you have to remove here? It gives N2O, means here you have to remove N2O. Suppose if I remove N2O gas, what happens here? 2 nitrogen is removed and 1 oxygen is removed. How many oxygens are remaining here? 5 oxygens are remaining. 5 oxygens are remaining means you have to form 5 water molecule here. Remaining, with the remaining oxygen, you have to form water molecules. So here only 2 hydrogens are there. Still how many hydrogens are required? Still how many? 8 hydrogens are required here. So you have to take 8 nascent hydrogens. Here already we have got what? Nascent hydrogens. Here only 2 are there, but we required what? 8 nascent hydrogen. So in order to balance that one, this is multiplied with 4. That's it. Now the process is over. You can cancel the remaining things. Nascent hydrogen get cancels here. Okay. Then what happens? 4 moles of zinc reacts with 4 to the 8 plus 2, 10. 10 moles of dilute HNO3. Giving, what happens here? Giving 4 moles of zinc nitrate plus what you will get here? N2O gas plus 5 times of H2O. So in the NCERT, they have given directly this reaction. Okay, If you want to remember, you can remember this reaction by practicing, otherwise you can go through the concept so that easily you can write this reaction. Okay, this is what the reaction of zinc with the concentrated HNO3 and dilute HNO3. They get oxidized to, always metals get oxidized to what? Metal nitrates only. They are copper nitrate and here is what? Zinc nitrate. And most of the time in the group 15, that is 3 mark question, they will ask like 2 plus 1 also. In that case what happens? Sometimes they are asked which gas is liberated when zinc reacts with dilute HNO3, that is N2O gas, that is nothing but laughing gas is liberated whenever zinc reacts with dilute HNO3. This thing you have to remember here. Next we will go for oxidation of non-metals. Now we will discuss oxidation of non-metals. One thing you keep in mind, non-metals are oxidized only by the concentrated HNO3. First point, oxidation of non-metals. That one, the first point is what? Non-metals are oxidized only by concentrated HNO3. So that one thing is very much clear here. For the oxidation of non-metals, you have to use what? The decomposition of concentrated HNO3 only. For everywhere, you have to use what? 2 times of HNO3. This on heating, this is being concentrated. It gives what? Water molecule plus 2 times of NO2 plus nascent oxygen. So for the oxidation of non-metals, you have to use only this decomposition reaction for all the non-metals. Here I will write iodine is oxidized to its oxy acid, that is HiO3. Okay. Next, sulfur is oxidized to its oxy acid, that is H2SO4, sulfuric acid. So phosphorus is oxidized to phosphoric acid, H3PO4. Then carbon is oxidized to CO2. These reactions we have to write now. I'll write first the reaction of that is first oxidation of iodine to the iodic acid with the HNO3. Now you will take, that is 2 times of HNO3. This is a concentrated HNO3. This on decomposition, what it gives? Water molecule, 2 moles of NO2, 1 nascent oxygen. Then this nascent oxygen reacts with what? I2. I2 combines with 5 nascent oxygen to form what here? I2O5. Okay. Already this is a non-metal oxide. Whenever non-metal oxide is dissolved in water, it gives what? Oxo acid. So this I2O5 further reacts with water. Already here water is also formed here. Reacts with water to form what? 2 times of HiO3 here. Now you see here, it gives only 1 nascent oxygen, but here 5 nascent oxygens are utilized here. So in order to balance these two, this is multiplied with 5. Okay. Now 5 nascent oxygens, these two get cancelled. I2O5 get cancels. Now you can write I2 combines with total 5 2s are 10 HNO3, 10 times of concentrated HNO3. Okay. Then I2 reacts with 10 times of concentrated HNO3. Here water molecule get cancelled. So here total 5 water molecules are there. In that one water molecule get cancels. Remaining is what here? 4 times of water molecule. Then you will get 2 times of HiO3 plus you will get 10 times of NO2. 10 times of NO2 it is. So in this way you can write what? The oxidation of iodine to the iodic acid. So in the NCERT directly they have given this one. I2 reacts with 10 moles of concentrated HNO3 giving 4 moles of water, 2 moles of HiO3 and 10 moles of NO2. Okay. This is what oxidation of I2 to the iodic acid. Next reaction. Now oxidation of phosphorus, that is 2 moles of HNO3. Again it is concentrated. This on heating gives what? Decompose to give a water molecule plus 2 times of NO2 plus it gives 1 nascent oxygen here. Next what happens? This nascent oxygen reacts with what? Non-metals, that is phosphorus, 2 times of phosphorus reacts with what? 5 times of oxygen. So it will form what here? P2O5. Phosphorus pentoxide, it will form P2O5. This is the non-metal oxide. It is being acidic in nature. Again, it will be dissolved in water to give what? Oxoacid, that is S3PO4. Already we know that phosphorus is oxidized to what? S3PO4, that is phosphoric acid. So this is P2O5. This on dissolving in water. This on dissolving in water, it gives what? H3PO4. Since 2 phosphorus are there, we will write 2 times of H3PO4. So for this one, total 8 oxygens are there here. So here only 5 oxygen. So here we will take 3 moles of water. Automatically it will be balanced here. Total 8 oxygen, and here also what? 8 oxygens are there. Now what we will write is, in order to balance the nascent oxygens, here 5 oxygens are utilized. Here only 1 nascent oxygen is coming outside. So this must be multiplied with what? 5 times. So nascent oxygen get cancels here. P2O5, P2O5 get cancels. Then what you can write here? 2 times of phosphorus. It reacts with 5 to the 10. 10 moles of concentrated HNO3. And here how many water molecules here? 5 water molecules. Here 3 water molecules. This side 2 water molecules are remaining. Here these water molecule get cancelled here. 3 get cancels. Remaining is what? 2 water molecules here. So we will write remaining is 2 times of H3PO4 plus 2 moles of water plus what is remaining here? 10 times of NO2. But in your NCERT they have given like this. They have given white phosphorus, that is P4. Directly they have taken atomicity of the phosphorus, that is P4 they have taken. So for 2 phosphorus, these are the stoichiometric coefficients. So for 4 phosphorus you have to multiply with what? 2 here. So this will come out as P4 20 times of HNO3, that is concentrated, which gives 4 times of H3PO4, giving 4 times of water molecule plus 20 times of NO2. This is the reaction given in the NCERT. Simply it is for 2 phosphorus, and this is for what? 4 phosphorus. Directly atomicity of phosphorus is taken, that is P4 here. This is what? Oxidation of phosphorus by the concentrated HNO3. Now the oxidation of sulfur by concentrated HNO3. Already we know that sulfur is oxidized to sulfuric acid. First we will take 2 moles of HNO3, that is concentrated, which on heating gives it undergo decomposition to give H2O plus 2 moles of NO2 plus 1 nascent oxygen here. These nascent oxygen, they will react with what? Sulfur to form sulfur trioxide. 1 sulfur combines with the 3 nascent oxygen to form SO3. So in order to balance this nascent oxygen, 3 oxygens are utilized here. Here only 1 is coming outside. So it is multiplied with 3 so that you can cancel easily here. Next, already we know that this sulfur trioxide, it is a non-metal oxide, which on dissolving in water it gives what? Oxoacid, that is H2SO4. Now if I write, this is SO3, again it is dissolved in water, it reacts with water. Already water is also available here. So what it will form here? H2SO4. So in this way sulfur is oxidized to sulfuric acid here. Now what happens here? SO3 get cancels, 3 nascent oxygen get cancels. Remaining everything you have to write as it is. Sulfur combines with how many moles of HNO3 here? 3 to the 6 it is. 6 times of concentrated HNO3. 6 times of concentrated HNO3 giving water molecule. 1 water molecule get cancels. Actually here 3 water molecules are there. So this side 2 water molecules are remaining. That I will write 2 water molecules remaining here. Next 3 to the 6, 6 moles of NO2 plus what is the main product here? H2SO4. This is how sulfur is oxidized to the sulfuric acid by the concentrated HNO3. So this is what the actual reaction. Okay, but in the NCERT they have given AC8, so that remaining all are multiplied with 8 here. This is 48 HNO3, concentrated HNO3, and 8 to the 16 water molecules, and this is 8 6 48 NO2 molecule, and this you will get it as 8 times of H2SO4. This is the reaction given in the NCERT. Actually, this is the reaction they have given with what? acid. That's it. Okay, this is what the oxidation of sulfur to the sulfuric acid. Next one, oxidation of the carbon. Carbon is oxidized to carbon dioxide. It is. Now the last one is oxidation of the carbon to the carbon dioxide. So we will take 2 moles of HNO3, that is concentrated. Again, this one decomposition gives what? Water molecule plus 2 moles of NO2 plus it gives what? 1 nascent oxygen. We know that this carbon reacts with 2 moles of nascent oxygen, 2 nascent oxygen to form what here? CO2. This is again non-metal oxide. Whenever it is dissolved in water, it gives what? H2CO3 also. So you can write like this. This is a CO2 combines with water. Already water molecule is there to form what? H2CO3. So this is what the reaction you can write. But here 2 nascent oxygen, only 1 is there. This must be multiplied with 2 here. So that 2 nascent oxygen get cancels. CO2 get cancels here. Next what happens? 1 water molecule get cancelled. Still 1 will be remaining here. Actually 2 water molecules are there. 1 get cancels here. So what you can write here? Carbon combines with 4 moles of concentrated HNO3. Okay, giving that is 2 moles of NO2 plus this is 1 mole of water. Here 1 mole of water is remaining here because 1 mole is get cancelled. Still 1 mole is remaining plus H2CO3 it is. But in the NCERT they have written like this. This one you can split and write it as H2O plus CO2. In total, in the NCERT book they have written NO2 plus 2 moles of water plus CO2 they have written here. So this can also be written as 2 moles of NO2, so that is 2 moles of water plus CO2. If you combine these two, you can write it as H2CO3. Otherwise, if you split these two, you can write it as 2 moles of NO2, 2 moles of water and 1 mole of CO2. This is how the carbon is oxidized to CO2. Okay, same everything I will write here. Carbon 4 moles of HNO3. This is concentrated HNO3. This is what oxidation of carbon to the carbon dioxide, or else you can write it as H2CO3 also. Okay, this is what the oxidizing property of the HNO3. In this one you have to concentrate mainly the oxidation of copper and zinc with the concentrated HNO3 and dilute HNO3. Keep in mind, copper with the dilute HNO3 it gives what? NO. Copper with concentrated HNO3 it gives what? NO2. Zinc with the concentrated HNO3 it gives NO2. Zinc with the dilute HNO3 it gives what? N2O. These are very important points you have to remember. Okay, thank you.